My name is Justin Hutches, and today I'm going to be talking about the bomb calorimeter experiment for Group 2. A little introduction. The bar oxygen bomb calorimeter is used to measure heat released by combustion of both solid and liquid samples. This is considered to be the most accurate way to measure heats of combustion. In this lab, our main objectives are to become more familiar with how this bomb works, to determine the thermal capacitance and the heat of combustion in this calorimeter also. Background and theory. Heat of combustion is the number of heat units released when combined with a constant volume and oxygen in a confined space. We're going to use the first law of thermodynamics, which is just heat of combustion is equal to mass times specific heat times the rise in temperature. Your mass times your specific heat is your thermal capacitance. When the calorimeter is the thermodynamic system and a known fuel is being burned, you're going to use this equation, which is the thermal capacitance is the heat of combustion over the rise in temperature. And whenever you're burning an unknown fuel, you have to find the heat of combustion itself. So you're going to multiply the thermal capacitance by the rise in temperature to find that out. Some real world applications. It's used in many industries to do analysis, such as in the coal industry, explosive like fireworks and stuff like that, oil and gas, food and nutrition. It's used all the time to just do constant analysis on how heat affects these different things. The apparatus itself, this is a diagram of how it's set up. It consists of the igniter, the bomb itself, which is number 2 right here, the laptop with the proper software, analog to digital converter, the water bucket, which is this that sits inside of the jacket itself. You have your thermocouple, which is number 6 that comes down into the water bucket, and your stir motor, which is going to stir the water around inside to keep all the water the same temperature. The bomb itself just consists of the lid, the housing, and the locking ring, which keeps it compact so no water can get inside of it. For setup, first you have to start off by preparing the bomb, which is you have to add the benzoic acid into the crucible, connecting the ignition wire and adding water, and placing the lid on top so no water can get out of it. Once that's done, you're going to apply the oxygen hose to the bomb to pressurize it to 30 atm, and then you're going to remove it and depressurize the system by unscrewing the relief valve and tightening it back up. Next, you have to prepare the water jacket, which is just adding 2 kilograms of water to the bucket and placing it inside of the calorimeter jacket. Then you have to prepare the instrumentation. That is just by starting the computer, opening the software, inserting the thermocouple into the bracket, and making sure that it's taking the right kind of data that you want for the experiment. Next, you have to assemble the calorimeter itself. This consists of lowering the bomb down into the water, connecting the electrical leads to the terminals, and then placing the jacket over the entire unit. Once that's done, you can position the calorimeter lid, place a drive belt on the motor and the stirrer pulleys, and then you're set up to start the experiment. To run the actual procedure, you're going to let the water get to room temperature. Once this is done, you're going to take data for 2 minutes. After the 2 minutes is up, you're going to press the ignition button to ignite the fuel inside of the calorimeter or the bomb itself. And then you're going to wait for that temperature of the water to get back up to equilibrium. And once it reaches equilibrium, you can stop the experiment. After that's done, you're going to go through the entire experimental setup, and you're going to run through this entire procedure again with an unknown fuel, and you're going to determine the heat of combustion for that fuel. And then after that, there's a part to disassemble everything and get it back to normal. These are some results that I calculated from the equations earlier. We were given 2 kilograms of water and 3 kilograms of stainless steel. I went online and I found the specific heats for water and stainless steel. Using the equations from earlier, I came up with about 9,872 joules per degree Celsius. Using that, I was able to go to the next part, which 1 gram of benzoic acid is equivalent to 26.38 kilojoules of, that's your heat of combustion value for benzoic acid. So I used the equation from earlier to find a 2.67 degrees Celsius rise in temperature. Some error that could be included in this is touching the thermocouple, which could change the temperature that you're reading on your computer. Not allowing the tank to reach equilibrium, which could throw your temperature rises off, and not following proper setup of the bomb in the tank, as shown before. Some safety. We're going to follow all LSU standards. Any precautions that were needed to. This will include safety glasses, pants, closed-toe shoes. As you stated earlier, if you spill water with the water bucket transport, we're going to have to watch out for that. We're messing with electrical wires and water, so try not to get anyone electrocuted in the process. And these are my references, just the lab manual and another website I found some stuff on. That's it.